we've seen how the Lotka-Volterra graphs work and how to read it. Now we can use the simulator, either the Excel sheet that I have linked or the Wolfram website, to keep put in our own values and make our own graphs, which should match up with what we just studied. So if you download the Excel sheet, this is what you should see. You would only change the numbers over here in red. The graph over here is the population graph, so it shows basically the number of species you have at a time. This is the time graph, the time axis. This on the left side, the right side is our Lorca Volterra competition graph. And so, what I want you to first emulate is a scenario when one species clearly outcompetes the other. So what I have is set to now is species A having facing very little competition. That is the competition coefficient. So it's 0.1 for species A. So it is thriving. And species B is facing a lot of competition from species A. So it's pretty much petering out. And we see a clear winner on the graph. If I wanted to reverse that, I make species A face a lot of competition, species B not so much. And I see species B, the gray line coming up on top. And if I want to do it on the Wolfram, if you wanted to see the stable and unstable equilibrium, so when you reset the graph, mm, yep, when you reset the graph, it should be at stable coexistence, where all the lines point to the middle. The competition that species are facing are pretty much equal. That's 0.63, 0.53. If I want to make it unstable, then the competition should be much higher. So I'll move them closer to 1 and 1. Let's wait for the graph to change. Yeah, I think this is will unstably, let's see. Yeah, so these are moving away from the convergence point, the lines. So both the species need to be fiercely in competition with each other to um, basically be at an unstable situation where anyone could win. But it depends on other factors over time and where you start from. So you can plug in your own numbers, you can change any of the factors, you can look into the actual math, you can look into a lot of other predator play models if you're interested, and use these two resources to make your own graphs. Thank you.